One problem with old mopes like Simson are the turn signals. The reason are the flasher relays, which are just bimetal switches. That is pretty unreliable with the wrong load or a defect bulb. Most of the time it just does whatever it wants and consumes a lot of current while doing so, because these are really old, inefficient bulbs. That is why I teamed up with a friend to mod the lighting system of his Moped. In this video I will concentrate on the turn signals, the daytime lights and the brake light. He also has underbody lights with RGB LEDs installed underneath his seat and tank. We will include those in the circuit, but it's not the main focus. With that being said, let's get started. First of all, we have to build the turn signals itself. My friend made those custom sized PCBs with stripped Cooper traces, which will fit nicely inside the case later. We need 2 for each turn signal, 1 for the front and 1 for the back, so 8 in total. I soldered 4 orange LEDs on each front and back side. Also 2 white LEDs on each front side and a RGB LED on the front and back side. To keep the circuit simple and reliable, I used bridge wire to connect all orange LEDs in parallel and did the same thing with the white LEDs. But we need one common anode, so I used bridge wire again to connect the plus terminal of the orange, white and RGB LED. Almost done. Now I connected the anodes together of the front and back PCB and the cathodes of each color individually. In the end I got a wire for the common anode and the cathodes for orange, white, red, green and blue. But the red LED of the RGB LED on the front is not connected, because we only want red on the back for the daytime lights. Well, that was a bit complicated. Now something simple, like the brake light. I just soldered 18 RGB LEDs on this custom sized PCB, and I used bridge wire to connect all of those in parallel. At the end I soldered wires to the common anode and each color. It is also a good idea to test the LEDs whether they still work fine in the end. Now the controller board. Here is my schematic, and as you can see I chose the AnyTiny 85 again. It's just such a small and cheap microcontroller, it's pure awesomeness. So how does this work? We have a turn signal switch up here. The left and right orange LEDs get separated and go to their switch, then to the beefy resistors. And here is the input 1 of the AnyTiny. When the switch is not triggered in any direction, we have no voltage drop here. That means for the AnyTiny the daytime lights stay on. This is output 2. Then it has 5 volts and lets this NPN transistor act as a switch, which is closed. So these LEDs light up. All white LEDs and red on the back of the turn signals. But if we close the turn signal switch in any direction, we have voltage at this input. This puts 0 volts at the daytime light switch, which turns them off, and 5 volts at the output 0, which closes the turn signal switch, and the turn signals light up. Here is also a simple delay function to let those flash like the real deal. That was the microcontroller function. Of course you also have to build the circuit for the AnyTiny, like I did right here. But it is a really simple one. I bet you can do this. And don't forget to program the AnyTiny. And if you're wondering where the second BC140 transistor is, we place it on the PCB for the resistors, just because we can. Only a few parts are missing. The 4 switches to activate the red, green and blue underbody lights, the switch to activate the hazard lights, which just turn both turn signals on at the same time, and those beefy resistors, because we are really wasting power here with this amount of LEDs. For example, the green switch here turns on 32 underbody light LEDs, 18 brake light LEDs and 8 turn signal LEDs. All green of course. 58 LEDs in total. Here is a basic example to calculate the values. We have 58 green LEDs with a voltage drop of 3.2 volts at 20 milliamps. And our voltage source is a 6 volt battery. So our resistor must have a voltage drop of 6 volts minus 3.2 volts, so 2.8 volts. And a resistance of 2.8 volts divided by 58 multiplied by 0.02 amps, so around 2.4 ohms. And a power rating of at least 2.8 volts multiplied by 0.02 amps multiplied by 58 equals around 3.3 watts. We use two 5.6 ohm 5 watt resistor in parallel, which equals an 2.8 ohm 10 watt resistor. I also wrote the resistor and power ratings on the schematic, and also how many LEDs we have in each string. You can build it just like that if you want to be lazy. The brake light is pretty dim when the brake is not used, because of those two resistors in series. But if you use the brake, this switch closes and the LEDs get brighter. Last step would be wiring and mounting all parts on the Moped, which was in retrospective the easiest part. It's really just an act of looking at the schematic, connecting the wires with solder, looking out that the PCB traces do not touch any metal things, connecting wires to the terminal strips, and so on. It really looked neat at the end, and because we took our time and didn't rush, everything worked on the first try, which is pretty rare. All I can say at the end is that this Moped will stand out and be safer on the road. I hope this project inspired you to build something on your own. It doesn't need to be this complex, simple solutions are mostly the best. As always, thanks for watching, don't forget to follow me on Facebook, Twitter or Google+, and I will see you next time.